All right, guys, we're doing cylinders today. So the rest of our notes for the rest of the year, we're going to take kind of a set of notes for each type of geometric solid that we talked about yesterday. So we're going to have a day for cylinders, a day for triangular and rectangular prisms, a day for other regular prisms. We're going to have a day for cones, a day for pyramids, and a day for spheres. So on each of those days, we're going to be talking about the same two things over and over again: surface area and volume. Okay, that's the plan for the rest of the year. It's pretty systematic. Okay, so we are going to find and use surface area and volume of cylinders, look at cross sections. We're going to identify 2D shapes that create a cylinder when rotated, and we're going to approximate the surface area and volume of real world objects. Okay, so a cylinder is a three-dimensional figure that has two congruent parallel bases. So the bases have to be congruent and parallel. Okay, we talked about yesterday how we can't have one base like this and another base like this, because those would not be congruent or parallel. Okay, I need a stack of pennies. Where did my pennies go? There's a dime in my pennies. All right. Here's a fun thing. We'll talk about that in a minute. I just wanted them ready to go. Okay, so here we have two kinds of cylinders. We have a right cylinder. A right cylinder has its axis perpendicular to its base. So you see this dashed line that connects the center of one base to the center of another base, the other base? Okay, that one is the axis. That's the second blank. Okay, the top blank is the distance from the base to another base. Okay, that's the perpendicular distance, so that is the height. Okay, the name of that segment is the altitude. The altitude is the geometric figure. It's an actual segment. Okay, the height is the length of that segment. But a lot of times we are a little like loosey-goosey with the vocab, and we'll say altitude and mean height and vice versa, okay? So, but strictly speaking, this is the length of the altitude. Okay. So the height always has to be perpendicular to the base. Everybody see that? Okay. So I have here a little stack of pennies. Everybody see it? They kind of approximate a cylinder. Now this cylinder has a volume, right? Certain amount of stuff that fits in there. What happens if I make it so that it's slanted? Can everyone see that now? I'm going to show the camera. Did I change the amount of stuff in my little slanted cylinder? Okay, so as long as our two cylinders have the same height and they have congruent and parallel bases, what do we know about their volumes? They're going to be the same. Some guy named Cavalieri figured that out. So that's his little principle. Okay. All right. We talked about these guys yesterday too. This is a net. It is the 2D object that is made up of the surfaces of our 3D figure. So imagine or unfolding or unwrapping a 3D figure. So for this, I cut this open in the name of mathematics today. Okay, we're going to pretend like this label goes all the way to the top and the bottom, right? If I take this label off, it's going to make what shape? A great big rectangle. So you can see that this net gives us a cylinder, right? We got a lid, those are the bases. Okay. Is that in your way? So, it'd be nice if we could use this picture and develop an understanding of how to get the surface area for this figure. So if this came from my cylinder, that was kind of gross, sorry. You see that this is the height? So what is this part of my rectangle? Yeah, this is the height of my cylinder. Okay, that was the fun one. Okay, the next part gets a little bit more exciting. You see this? It's kind of like the perimeter of my circle, but when the perimeter is on a circle, we call it starts with a C, circumference. Okay, so this circumference, does anybody remember the formula for that? Not pi r squared, that's the area. 2 pi r, very good. Okay, so in order to make this cylinder work, you see that this edge of my rectangle has to wrap around the circumference of my circle. You see it? So, what is this length? They're the same. Yes, the circumference, right? Well, look at it.
Oh, never mind. I got it.
Right? Okay. Okay, I was just doing this in the video. Okay. Okay, so this is just our circumference. All right, so basically, we have in our surface area, we have a lateral area. And the formula for the lateral area is just this rectangle. How do we get the area of this rectangle? Yeah, base times height. So the base is going to be the 2 pi r. Times the height. Okay, now if I'm looking at the total surface area, that will be the lateral area, which is our 2 pi r times h. This is the lateral area, plus how many bases?
2.
Yeah. So for a circle, what is the area? This is the base area. Yeah, pi r squared. All right, so we got 2 pi r squareds. Okay, so that's 2 bases. So this is the general formula. Like the surface area is your lateral area plus however many bases you've got, right? Okay, specifically for a cylinder, the lateral area is what we found and then 2 of the circle areas. Easy peasy? Okay. The area of the resulting rectangle is our lateral area of the cylinder. The surface area, oh my God, brain fart. Surface area of the cylinder is the sum of our lateral area and the bases for that are the circles. Okay. We kind of already went through this, but it kind of just fit up there all nice. So a couple of different ways you can think about the lateral area. You can think of it as 2 pi r times the height. Or if they give you the diameter, you can just use diameter times pi, or pi. Is it pi times diameter or diameter pi? Pi times diameter, I think, times the h. I probably use this one more. If you feel like you want to rewrite the formula down here, you may, but I think we already wrote it, so I'm just going to keep it moving. Good? Okay, here we go. Oh, really quick. This is important because some of us like to be cute with our handwriting and use capitals all the time, or like always lowercase, or like loosey-goosey, doesn't matter the capitalization. Now it matters, okay? You don't get to pick anymore. Anytime you have a lowercase letter, lowercase, that has a specific meaning. It means that it is a linear dimension. Okay? The length, the width, the height, those are all linear dimensions. The radius is a linear dimension. They all get lowercase letters. Okay, look at this. Look at this base. Is that linear? That's two-dimensional, right? So this base has a big capital B. So our capital letters we use for 2 dimensions. Okay, this might seem like an arbitrary thing, but think about it. If I have a triangle, oh my gosh, that was the worst triangle I've ever drawn. Okay, here's my height of my triangle, and here's my base. Didn't we always use a little b on that one? Because that dimension is linear. You guys see the difference between this b and that big B? That big B is an area already. It's got something times something equals an area. This is just like a linear one like the height. Cool? All right, let's go. No. Well, all right, volume is going to measure the what contained in what? The space contained inside a solid. Okay, we're going to measure volume in cubic units. So it's a little bit hard to think about actually with a cylinder first, because a lot of us are much more familiar with a rectangular prism. Like we all know that in order to get the volume of a box, we do length times width times height, right? I just have a tissue box. So my length and my width together make my base with my big B. Everybody see what I'm talking about? So the big B already has 2 dimensions. So when I multiply the big B by the height, I get my 3rd dimension and I get a volume. I get 3D. Everybody okay with that? Yep. Okay. So if you think about this base as already having 2 dimensions, if I take something that has 2 dimensions and I multiply it by a 1-dimensional thing, like this is going to be squared, this is going to be to the 1st power, I'm going to get something to the 3rd power that's cubic units. So this is going to be square units times linear units to the 1st power. Okay, when I multiply same bases, what do I do to my powers? Add them. Okay. So when I'm multiplying my same bases, I'm adding my powers. Isn't u squared just u times u and then times another u? Don't I just have like u cubed, right? That's our length times width times height, cubic units. Everybody see what I'm talking about? Okay, perfect. So we have to get cubic units. All right, the base inside of our volume. For the base in our volume is the area of our circle. So that would be pi r squared. This is our big B. And then we just multiply that with the h. So do you see that our units are already being squared because the radius is being squared? Okay, that's what gives us our power of 2. So if we do inches squared times inches, now we have inches cubed. Cool? Okay. All right, let's do some examples. Let's rock and roll. All right, we're going to find the surface area and volume of our cylinder. Let's draw a quick little net. We're leaving answers in terms of pi for this one. All right, let's start with the lateral area. What is this length? Remember, it has to go around the circle. So what is the circumference of this circle? What's our radius? Okay, so if I do 2 times 6, I get 12. So this is 12 pi. Everybody okay with that being 12 pi? Okay, what is the height of this little rectangle that we made? Yeah, this is just that same 9. Okay, so our surface area is going to be our lateral area plus how many bases? 2 of them. Okay, the lateral area is going to be our circumference, 12 pi times 9. Plus our base over here. This is our base. Our base is pi r squared, so pi times 6 squared. Right? But we have 2 of them. So it's going to be 2 times 36 pi.
So we have to put them in brackets.
You can use parentheses if you want.
Okay.
Sometimes I plug everything in at once and then I have a whole bunch of parentheses in there and it gets a little confusing about which parenthesis goes with which parenthesis. So it's just like an organizational strategy to use a bracket instead of a parenthesis. But they do the same thing. They're just grouping symbols. Okay, good question. All right, so what's 12 times 9? Okay, 108 pi plus 2 times 36 is 72 pi. Add those together, what do we get? What? Okay, 180 pi. What kind of units? Just regular feet? Well, it's an area. Is it cubed? It's squared. Okay. Woo! Okay, area is 2D. Okay, so we should have a power of 2 for our units, right? The dimension matches the power of the units. Okay, so this is our surface area. All right, let's do volume. Volume is actually friendlier than surface area. Okay, so it's just going to be the big B times the little h. We already know what our big B is. What is it? Okay, times, what's the height? 9. What does that give us? $324 pi feet to what power? Cubed. Okay, so this is 3D, so it has a power of 3. Questions? Okay. No one's crying. You guys are doing pretty good. All right, do you guys want to do another net? Did that help? Did it help to do the net? I don't know, I'm asking. All right, let's just do it. Okay, these are the worst circles I've ever drawn. It's fine. So, remember that this has to go all the way around our circle. Okay? What's my radius? Okay? So, what is the top of the rectangle? Okay, remember that this is the circumference. This is 2 pi r. Okay, 16 what? Yeah. Okay. How tall is my cylinder? Yeah. Okay. Should we also do the area of the base? This is my base. My B is pi r squared, and my r is 8. So 64 pi. All right, let's plug them in. Our surface area is our lateral area. So 16 pi times 9. This is our lateral area. Plus how many of our bases? Okay. And they're each 64 pi. You can just round it to the nearest hundredth. You can put the whole thing in the calculator, round the whole thing to the nearest hundredth. Why does it look green outside? Huh? It looks like a tornado's percolating. This is the color the sky gets when it's tornado time. We're all gonna die. Okay, what do we get? 8 what?
854.51.
What?
0.51.
0.5. Okay, is that what everybody got?
Yeah.
Okay, what kind of units? Feet to what power? Good, squared. All right, let's do the volume. We already know the base. So the base is our 64 pi. Okay, times our height, which is, this is our base, this is our height. What do we get? $64 times pi times 9. I'm getting 0.56. Okay, what kind of feet? Cubic feet. Okay, we got 3 dimensions. We need a power of 3. Okay. All right, let's do this one. This one looks like it's going to be hard, but it's real easy. You're going to love this one. All right, let's start. Okay, so what do we know? We know the volume. We know V. What else do we know? That the diameter is important because it tells us the what? Yeah. So what's the radius? Okay. That's another thing we know. We just have to find the what? Okay, so let's start with the formula. So volume equals big base times height. What's in our big base? Pi. It's the circle, right? R squared, good. And then times height. So can't I just plug in everything I know? All right, let's do it. So the volume is 72 pi. And now I've got pi times my 3 squared times my height. 3 squared is what? Someone said 6. I will find you and haunt you. That was definitely a threat. I'm not kidding. I know. I meant it.
What happens if your contract doesn't get
Okay. It's too late. I'm tenured. Okay, cross out the pi's. If you divide both sides by pi, they go away. Divide both sides by 9 and we get, yep, the height is 8 what? Good. Okay, there centimeters to the first power because the height is linear. Okay. Guys, that's it. That was the end of that page. Here we go. That was a fun one. All right, this is going to be kind of fast because we've already done a couple. You know what I mean? We're going to go. All right, we got a can of pumpkin. Got a height of 12 and a diameter of 6.8. You guys want to draw a picture? No? Lame. Okay, so the height is 12 and the diameter has to go through the center of the base. Ooh, that was a little crooked. If the diameter is 6.8, what is my radius? 3.4 is my radius. Okay, it says find the area of the label. Okay, this is my giant can of soup. Pumpkin soup. Okay, I'm taking the label off the can. Is there a base on this label? This is just the rectangle part, right? Yeah. Okay. So, what are the dimensions of my rectangle? The rectangle is going to have this whole circumference times this height, right? Whoops, this is the worst picture. Oh my gosh. I might get fired for this picture. Okay, so this circumference is what? 2 pi r? All right, my r is 3.4, or I could just do diameter times pi, right? 6.8 pi. That's my rectangle. So if I just want the label, this is my lateral area only. So I'm doing 6.8 pi times 12. Okay, we're rounding to the nearest whole square centimeter. I'm getting 256.35. Is that what you guys got? Centimeter. Whoops. It did say whole centimeter, right? 256. Centimeters squared. All right. I'm cranking on it with the can opener. Okay, I've opened my can of pumpkin and I've removed the lid because I don't want to slice open my hand when I'm digging out the pumpkin. Okay, how many bases are on my can? 1. So if it's after I've opened it, I'm only going to have 1 base. So my surface area will be my lateral area plus how many bases? 1 base. Okay. Well, I already know what my lateral area is. It's this 6.8 pi times 12. So I'll just plug that in. 6.8, did I say pi in there? There's a pi. Okay, that's my lateral area plus, what's my base? Yeah, pi, and my R is 3.4. Okay, you can put that whole thing in your calculator, round once at the end, not in the middle. Oops. I'm getting 293. Okay, area is in square units. It's 2 dimensions. I should have a power of 2. Questions? All right, let's keep on rocking. All right, how much pumpkin am I going to fit in the can? Am I talking about the stuff that makes the can? Or am I talking about the room inside the can? Yeah, so what am I asking you to find? The volume.
What's that word?
What? Truncate. Oh, it's a type of rounding. Truncating is when you just like chop off decimal places. So let's say that I had 103.9. The rounding rules would say that I would go to, hey, the regular rounding rules say I go to 104, right? But if I truncate, I just chop off the decimal place and I go to 103 no matter what. It's my favorite type of rounding because it requires the least amount of thinking. Okay. So, I'm after volume. Volume is my base times my height. Okay, do we need to shut the windows? All right, our big base is pi times 3.4 squared. And our height is what? What's the height of the can? 12, okay. All right, so we're truncating. So whatever the decimal is, we're just chopping it off. I got 435. Is that what you guys got? Yeah? Okay. So what kind of centimeters? Cubic. Okay. Volume is 3D. So I need a power of 3 on my units. Okay, we've already done slicing. Remember how we cut the cheese yesterday? Cut the cheese. All right, so we've already done this, but now we're gonna actually give it a name. A cross section is the intersection of a plane and a solid. Okay, it is the shape of the two-dimensional slice of the solid that you get when you slice with a plane. So here I have my cylinder. I sliced it with a plane, and what is this little intersection? Yeah, it's a little circle. Isn't it cute? Here. Look at how friendly he is.
Ew.
What's wrong with you? Don't be rude. All right, what if we did a vertical slice instead? Like perpendicular to the base. Okay, here, I'm going to help. Here's a vertical slice. Yeah, what do we get? A rectangle. Does everybody see it?
Yeah.
Okay, what 2D shape, when rotated, would create a cylinder? We did this yesterday. Someone said calculator? Yes, calculator. Right? Yes, a rectangle. Thank you. Yeah.
Oh my goodness.
Okay, I am going to draw the picture for the video, but we already have the picture, so it's fine. So here's my axis. Okay, here's my rectangle. I'm going to rotate it around my axis. And I'm getting a cylinder. Right? Okay, perfect. Is that really the end?